What is rectilinear motion? It's a fancy way of saying straight line motion. Okay? Rectilinear motion is just a fancy way of saying straight line motion. Okay? So, and you know all these very, very basic equations. If you want, I'll write it down for you, and you can figure out what they are. Okay, so when did you study this? 9th standard, 10th standard, 9th, 8th, 8th standard. So obviously you have forgotten it. Huh? So you have forgotten it, right? That is why we are studying again. Now, these are the things. Basically, these come out of what is the thing between time intervals t1. You have two time intervals t1 and two time markers t1 and t2. The displacement is x2 and x1. Okay. Therefore, from a reference point, okay, the distance traveled is, first, then velocity is nothing but x2 minus x1 divided by t2 minus t1. The velocity is x2 minus x1, okay. Now, writing it in terms of calculus, what you have is delta x over delta t and limit delta t tending to 0. So, this is the instantaneous velocity. Velocity is delta x divided by delta t, limit delta t tending to 0. That's your instantaneous velocity. Okay. Then, now it is very common amongst engineers and scientists too to say the differential with respect to time. The differential with respect to time is indicated as dot. Okay. So x dot is velocity, and x double dot means d squared x over dt squared, which is nothing but acceleration, right? That is dv over dt, which is d squared x over dt squared. So that is x double dot. So in scientific notation, a dot means differential with respect to t. Okay. Now we have certain straightforward equations. We have some straightforward equations, and that is v equals x dot, that is equal to dx over dt, which I have already shown you. Okay. Then a is dv over dt, that is equal to d squared x over dt squared, and that's denoted as x double dot. See how very stupid of me. Okay. Then you automatically know that a dx equals v dv, okay. A dx is v dv. So these are the basic things that you already know. Maybe in the 9th standard you may not have studied in these differential forms, but whichever way you have studied, these are all simple expressions. Now, what do these things mean? It means, suppose the possession of a particle with respect to some reference point okay, is given as x equals pt cube minus qt squared, where t is the time, t is the time interval, okay. X is equal to pt cube minus qt squared. Find the possession of the particle at a given time, at any given time. This is very easy. I don't have any problem with this, okay. Also, the velocity and acceleration. So you know the position as pt cube, so you just have to substitute t. You know p and q, so substitute t and you can get the position. And for velocity, you differentiate it with respect to t. That will become what? 3pt squared minus 2qt will give you the v. And you know q and p, so you can find the velocity. Acceleration, differentiated twice, then that will become how much? 6pt minus 2q, right? So you would do that and you can. So very, very simple 8th standard question. I'm not going to, okay. Now, there is a problem. By the way, simple problems like these may be asked in your part A question, okay? Because most of the homework I give you don't involve numericals, right? But don't be misled that your 2-mark questions will not have any number problems. You may be asked to solve some simple number problems even in the part A 2-mark questions, okay? So I just want to make sure you are not under some wrong impression that 2-mark questions will not have numbers and stuff like that. No, don't be under such a wrong impression, okay? A is given as alpha t minus 4, okay? At t equals 2, v equals 4. At t equals 1, v equals minus 1. Okay? So solve for alpha and v. Okay? Solve for alpha and v naught. That is, solve for the initial velocity v naught and the acceleration, or no, not the acceleration, and alpha. Okay, solve for alpha and V naught. Okay, V is nothing but integral a dt. Okay, so V minus V naught equals alpha t squared over 2 minus 4t. Okay. So from these two conditions, you can substitute here and you can solve for alpha and V naught. You can solve for alpha and V naught from these two conditions. So these are the types of problems, very simple, just straightforward expressions given for integration, differentiation, and substitution. So there is nothing to it. Agree? Okay. Now, how many of you have looked into that Fosbury flop? Did you find it interesting, Hari? Out here, nobody. Okay, Anashura and Anuradha. Oh, quite a few. That's good. Did you find that, Srinidhi? Did you find it interesting? You did? Why did you find it interesting? Huh? Why did you find it interesting? Anyway, because that's also part of dynamics. That is why I am bringing that into the discussion here. So these things solve and you will get, put t equal to 1, v equal to how much, and you can get v naught. Absolutely no problem, because there are only two unknowns, v naught and alpha. So that's all there is to it. Now, what is escape velocity? What is escape velocity? That is the minimum velocity required for any object to escape the gravity of the earth. Okay? Now, how does that come about? Supposing you have, this is the earth of radius r. Okay? Supposing you have the radius r. Okay? Now, sorry, I will draw the radius of the earth as okay, fine. Radius of the earth r, okay, and I have at a distance x, okay, a equals minus g times r squared over r squared, okay, where r is equal to r plus x. Okay. Therefore, a equals minus g times r squared over r plus x whole squared. Okay. Now, a equals dv over dx. Now, this integration is important. This integration is important. So far we have no problem. You understood this? So far we have no problem. But this integration, what does this, just the integral sign, what does that tell me? Tell me, please. What does the integral sign, what does that tell me? What does the integral sign, particularly with respect to the limits of the integration that I have shown, what does it tell me? It tells me that if my initial velocity is VE And the final velocity is 0, that it is not coming down, it is unaffected by gravity. Right? That is why the initial velocity, initial limit is VE, and the final limit is 0. So this is what is the significance of how you put the limits. It is not 0 to VE, it is VE to 0. And that manifests itself as a negative sign here, in fact. Okay, if you look at it. Okay? So if you do this, what you get is, this will be nothing but V dV, and that will be minus GR squared integral 0 to R of dx over R plus x whole squared. Okay, and if you do this, you get VE equals square root of 2GR. Now do this calculation please, 2GR. What is the radius of the earth? 6,400 kilometers, right? Huh? Do the calculation. Do the calculation. Square root of 2GR. Because why I want you to do the calculation, I need you to understand the importance of units. How will you put G? 9.81 centimeter per second squared. And R? Meters per second squared, 981, okay? Meters per second squared. So, then your radius? That is the point that I want, 10 power 3. Whatever be the units, you have to be consistent in units, because don't confuse me, sometimes you are saying centimeters per second squared, whatever it is, you have to be consistent. And that is why I am trying to tell you, please do the calculation independently and see how much you get. Make sure you understand the significance and the importance of units. Always keep in mind the importance of units. This is a trivial calculation that you are doing, but only to make sure that it gets registered in your mind, that any time you do these equations, you have to have units in your mind. Okay? So you do this and you will get this. Now, we come to something very, very interesting. We come to something very, very interesting, and that is called what is freely falling bodies? Okay, very good. Now, I'll go one by one with about 3 or 4 people, and whoever is interested can tell me in this case. How would you define a freely falling body? How will you define a freely falling body? Now for the next 10 minutes, I'm not going to write anything on the board. Okay? We will have a frank discussion so that you people understand what is a freely falling body. How will you define, Anuradha? What is a freely falling body?
A body that comes only under the action of gravity.
Okay. What Anuradha says is a body that comes under the influence of only gravity. Okay? There are no other forces. That is freely falling body. Okay, is there any other? Yes, just a minute, Harshvardhan. Yeah, what do you want to say? Huh? Instant velocity? Okay. Harshvardhan says instant velocity is 0. Okay, let us see whether that is correct, or what does he mean by that? Let us see. Initial velocity, or not instant velocity. Initial velocity, sorry. Initial velocity is 0. Okay. Anybody? Only gravity, that is. Okay, that's the same thing, because he is saying only under gravity force. Sandeep, you agree? So the acceleration of the body is only due to acceleration due to gravity. Okay, so this is what he says. Very good, excellent. Now please explain to me why do astronauts in spacecrafts like Skylab, okay, it's going around the Earth, it's orbiting around the Earth, these astronauts in Skylab, do they experience gravity or not? Do the astronauts and satellites? Huh?
Do the astronaut?
Astronauts and satellites. Right. Like you have the Skylab, you have so many people. Do they experience Earth's gravity or not? Suit? They are not wearing suit inside the capsule.
Out of the space, out of the air.
No. They are in orbit around the Earth. But are they experiencing gravity or not?
No, sir. They won't experience.
Gravity is used for different purpose.
No. My question, are they experiencing gravity? They are not experiencing gravity. How many of you have seen video clips, or in YouTube we can see astronauts floating inside the capsules, right? You can see astronauts floating inside the capsule. Do they appear to be under the influence of any gravity? Do they appear to be under the influence of gravity? So you think they are not under gravity? They are not under the influence of gravity? Yes?
The gravity of other planets also. But not its gravity.
I understand. Okay. Very less. And that is why they call it microgravity. Right? That is why they call it microgravity. Because my good friend Saravanan says, the gravity is very less, sir. Okay. Now I'm going to ask you one thing. Ladies and gentlemen, I think I may hurt my feet. But if I do hurt my feet, please help me out. Take me to the hospital, okay? Now, I'm here. I'm going to jump from here to the floor. I'm going to jump from here to the floor.